Hi guys, and welcome to the video explaining the last two sets of exam questions that I've set you. I'm going to go through the one, the ordinary level one and the higher level one. I hope that by going through both of these you'll see the different standards expected in both and what's required. Okay, so just in case I hadn't said it, this particular question that we completed, this is from an ordinary level paper. It's from the 2019 paper. And as I was going through most of the work that you guys were submitting, you found it really attemptable and really, really easy. So what I'm going to do is I'm going to go through the questions. The next slide on will have the marking scheme, so you'll see where the different marks go through. But I'm going to orally go through each of the questions now. So I'm going to start with A. So part A says, to which homologous series do both A and C belong? Now, so far we've only met three homologous series. We've met alkanes, alkenes, alkenes, and alkynes. Now, alkynes are triple bond. Alkenes are double bond, and alkanes are all single bonds. When I'm looking at A and when I'm looking at C, the easiest way for me to answer that question would be to draw it out. So I can see to A, I have CH4, and if I was to draw that out, it would end up looking like this. I can see that it's all single bonds, so they must belong to the alkanes. And if I did that out for compound C, I would see that too. So my answer for part A is your alkanes. Okay, part B then asks me to name A, B, C, and D. So A, I've already drawn it out for you, and when I'm trying to name these things, I would always try and draw them out to you. So A was C with 4 H's. So we know 1C is meth, all single bonds. So A is methane. Okay, B, we have C2H4. So as we're drawing this, we have to start with 2 C's, and we can only have 4 hydrogens in all of this. So if we can't remember, hydrogen needs to have 4 as its magic number. It likes to have 4 bonds. So it must have a double bond. So 2 carbons with a double bond. This guy is ethene. Okay, compound C, if we have a look, it's a little bit longer. We have CH3. I'm just going to draw it out actually. So I have 1, 2, 3. I have 4 carbons. So straight away I know that meth, eth, prop, that's bute. And then we have to assign each one their hydrogen. So on the first carbon there's 3 hydrogens. On the second carbon there's 2 hydrogens. On the third carbon there's 2 hydrogens. And on the final carbon there is 3 hydrogens again. So I can see that there's all single bonds, so this guy's called butane. And our last one, if I can make space, is C6H6. Now C6H6 is an unusual molecule, and that is benzene. Now that's just one of the ones you're going to have to know off by heart. But benzene, when you're drawing it in a ring, it ends up looking like this. Now where each of those corners are, each of those corners represent a carbon. So if I count each of the corners, I should have 6. 1, 2, 3, 4, 5, 6, and then my circle inside representing my delocalized bond. Okay, so moving on to part C. The forklift truck shown uses LPG as a fuel. The letters LPG stands for liquefied or liquid petroleum gas. And which one of the compounds listed above is the major component? The major component in this is butane. That will be compound C that we mentioned above. And the other main component of this is propane. So LPG is made up of propane, but the main ingredient is butane. Now notice they are both alkanes, they're both quite small. Remember, propane has 3 carbons, butane having 4 carbons. Okay, part D is asking you which of the compounds A, B, C, or D is produced in refuse dumps and slurry pits. Okay, so for D, our main gas there would be gas A, which is methane. And methane is produced in your slurry pits and in your refuse dumps. And which one is carcinogenic? Benzene. So compound D is benzene. And it's quite carcinogenic. And remember, all carcinogenic means is that it is cancer causing. Right, guys, the final part of this question is an experimental question. So the apparatus used is to prepare hydrocarbon B, and hydrocarbon B was your ethene, okay, ethene. And what we can see happens is that we have to tell them where the ethanol is, the alcohol is, which are the aluminium oxide and our heat source. So as I attempt to draw this out, and remember when you're drawing this out, take your time, use your ruler and use your pencil. There's your glass wool, and the ethanol will be there. It's soaked in the glass wool. So that's the first one. The second thing we need to identify is the aluminium oxide. Now the aluminium oxide should be down here in the middle of the test tube. So there's your Al2O3. And then it's asking you where the heat source should be. The heat source should be directly under your aluminium oxide, waving it over back and forth nice and gently. We don't want to put it directly onto the ethanol because ethanol is flammable. So that was an ordinary level question. People approached it quite well. There's no real major cause for concern for any parts. And for those of you who are interested, I've just included the marking scheme there, and you can see where the different marks are being assigned. Okay, so it's still a 50 marker questions from the 2019 ordinary level paper, and hopefully when we finish going through the higher level one, you'll see the difference in standard. So guys, this is your ordinary or your higher level question. It is taken, let me just double check, I think it's the 2017 paper. Higher level. I had said to you on Schoology, so I hope you all noticed, you did not have to do this part. We have not covered that yet, so I really hope you didn't attempt to do that. The rest, hopefully though, from your notes over the last while, you should have been able to complete. So I'm going to go through each of these now, and hopefully it'll make things a little bit clearer for you. I will include the marking scheme at the very end, in case anyone is having major issues with it. So if we have a look for part A, it says name the oil refining process shown in the diagram, and this process is called fractional distillation. Now remember, fraction just means part, and distillation to separate. So we're separating oil into its different parts according to their temperatures, their boiling points. That was part A, the first part of part A. And then it says naphtha is a mixture of hydrocarbons of similar relative molecular masses. We had to identify the physical property that is the basis for these hydrocarbons being isolated as naphtha in that process. So the physical property there is their boiling point. Things boil off in this with regards to their different boiling point, and depending on which fraction, and when I'm talking about fraction, it's kind of like a layer, depending on which layer they fall into, all depends on their boiling point. It then asks me, gives major use for kerosene. Well, kerosene can be used as airplane fuel. So this is part B. Some of you might have heard of kerosene lamps, kerosene cooking from home. It's kind of an old-fashioned way of doing it now, but airplane fuel would be the main part of it. And then the major use of residue. Now, we wouldn't have called this residue. We probably would have called it bitumen, the last fraction of this. But because it's the last fraction, we still know that it's all related. And the last fraction in this we would use for waterproofing things, or tar, covering road surfacing. Now, I'm not sure if any of you have ever watched oh, what's it called? The Shawshank Redemption. And you know the scene where they're on the roof and they're covering the roof of the prison with tar and stuff like that? That would all be your residue or your bitumen there that they're using in that. Okay, then we've part C. So this is when we're talking about high octane numbers and the idea that the higher the octane number, the better the fuel. So we're looking to the oil refining process that converts octane into 2,2,4-trimethylpentane. That process is called ionisation. Okay, so ISOMERISATION. So basically what you're doing is you're chopping octane up and sticking it back together as a branch. Okay, I'm going to draw out those two reference hydrocarbons because they're really important that we know them. So if we think about octane here for a minute, oct is 8. So I have 1, 2, 3, 4, 5, 6, 7, and 8. Then we have hydrogen attached to each of those. And we can see straight away it's all single bonds. So this guy is called our octane. And we know, I'm fairly sure I told you all of this in class, but when you're drawing out any of these, it's really important. The marking scheme changed a few years ago. It's really important that you include as many of the hydrogens as you can. So that was our octane. Our second compound that we had to draw was 2,2,4-trimethylpentane. So when we're drawing this, it looks absolutely horrendous. I'm always going to tell you to start from the very back. Okay, so pent just means 5 carbons. 1, 2, 3, 4, 5. And the A and E tells me that I have all single bonds. Before I add in any of my hydrogens, I want to deal with this mess. Now, 2, 2, and 4 are just indicators. So straight away I know that I have 2 things on carbon 2 and I have 1 thing on carbon 4. I know that those things are all the same, that I have 3 of them. So whatever is on carbon 2, whatever is on carbon 2, whatever is on carbon 4, they're all the same. And what that is, it's a methyl branch. So our methyl branch is just a CH3. And don't forget, it's bonded directly to the carbon. And now we fill in our hydrogens. 1, 2, 3, and making sure each of them have 4 bonds. Okay, the next part of the question then asks me to name the oil refining process that converts octane into ethyl benzene according to the following balanced equation and explain why I would want that. So this process, if you know, benzene is a cycle, it's a circular object, and this is called reforming, or can also be called dehydrocyclization. Now, I'm not going to lie, guys, these last few questions have been quite tough and they're expecting you to know your different methods of converting fuels to have a better octane number, and they're also expecting you to do this abstractly. Like to be able to identify there that your ethyl benzene, you know, that contains a circular structure, different things like that. Why would I want to do it? Because it all comes back to improving the octane number. We want to get that octane number as best we can so that the fuel does not knock. So like I said, we can skip the calculation, and the next question that we move on to is this guy. It says, on undergoing catalytic cracking, a gas oil molecule C18H38. Now that's 18. In terms of naming, we only go as far as 8 or 9, so we don't want to go any higher than that. It's broken into 3 smaller molecules, each of which is a hydrocarbon. 2 of these hydrocarbons are octane and propene. Deduce the molecular formula of the third molecule formed. Now when we're doing this, guys, I would always draw out my other 2 that they've mentioned. So the first one is octane, and I can see there that I have oct 1, 2, 3, 4, 5, 6, 7, 8, and then I have, sorry about that, I need to include my hydrogens. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So this compound in total accounts for C8H18. Okay, the next one that they get is propene. So when you're drawing propene, prop, P-R-O-P, that's 3 carbons. So meth prop, 1, 2, 3. Now this instance you need to notice that it ends in E-N-E, so that tells me that there's a double bond, and that's going to influence how many hydrogens I have. So remember, the magic number is 4. Okay, so right now there, that carbon is full, this carbon is now full, and that carbon is now full. So we want to see how many carbons and how many hydrogens this guy has. So it has 3 carbons, and if we count up 1, 2, 3, 4, 5, 6, it has 6 hydrogens. Now, we have to add the 2 of these together. So if I add C8 and C3, add them together like we were doing a normal math sum, let's see what we'd get. So I can see from this that I have used up C11 and I've used up H24. Now the only place these could have come from is my C18, H38. Okay, so what I need to do now is I need to take these away from each other. So I have C11, H24, and I'm going to take those 2 numbers away from each other. So I'm left over with C7, H14, and it's asking me to just deduce the molecular formula. It's not asking you to draw it, so that's perfect. So finally, guys, the last thing they're asking you to do here is draw octane, 2,2,4-trimethylpentane, and ethylbenzene. So I've already done octane and 2,2,4-trimethylpentane in previous questions here. So I'm just going to do ethylbenzene. So we know benzene, it's a 6-carbon ring structure. So I'm going to start off with my 6 carbons. And we know benzene is represented with a ring in the middle. Now, the ethyl bit means it has a branch. It doesn't matter whereabouts in the carbon you want to put it, but the branch means it has 2 carbons in it. So there's my first, and here's my second. And now we need to fill them with their correct amounts of hydrogens. So there's 1, 2, and then we've 3 of them here. Okay? So the marking scheme is attached onto the next slide as well for anyone who wants it. I hope that helps sort out a few things and helps you correct your homework as best you can. I hope you're all keeping well and stay safe. As I said, here's the marking scheme. It kind of goes through everything and assigns where marks are. Again, ignore this bit. We have not done it yet. I hope you notice the difference in standards also between your higher level and your ordinary. In your ordinary, it kind of allows you to piece it together from the question, but with the higher level, they really are expecting you to know your stuff inside out, upside down, and to be able to piece together quite abstract chemistry.